The topic is operators in Dart. So operators are used to perform certain operations on operand. Here we have two types of words. One is operands and another is operator. Operands represent a data, and operator is the sign, defines how operands will be processed to produce a value, to produce a result, like plus, minus. Let us first discuss about arithmetic operators. In Dart programming language, we have arithmetic operators. Let's see it. I will declare a variable int a and assign it 2, int b and assign it 3. After that, I will perform different operations on these two variables: addition, subtraction, multiplication. Let's first perform addition. Addition of a and b. For that, I will declare another variable c, and I will perform addition a plus b. Let us print it. The addition of a and b is $C. The addition of a and b is 5. Let's perform subtraction on a and b. For that, I will declare another variable d is equal to a minus b. So this will subtract value, and let us try to print it. $D. So I got the minus 1. This is subtraction. We have another operator in Dart, that is unary minus. That will reverse the sign. Let's say we got the result here minus 1 after performing minus 1. So this minus 1 is stored in D. Let's perform unary minus on this variable D. For that, I will declare another variable int, for example x is equal to this d variable. So this unary minus this d variable, I will use unary minus here. Let's try to print it and see what we get. Print x. You can see I got the 1. So this has reversed the sign. So this unary minus reverses the sign. We have another operator, that is multiplication. For that, I will use the same a and b. This multiplication will multiply two operands, where and then say f is equal to a b. Let's try to print this. Print variable f. The result will be 6. 2 and 3 is 6. Another operator is division. Let's copy this and paste it here. Call this division. Let's get here ff. For that, this slash sign is used for perform division. Let's print this ff. So I got the result here. If I use int here, int, and then try to run it, you will get, I got the error here. So be careful when you are perform addition. You may get addition, division. You may get, you may get double value result. So always use where when you are not specific what will be the result. So use where always in such cases. This where is used whenever when you don't know the data type of a variable. So in such case use this where keyword. Another operator is modulus, that will give the remainder. It gives the remainder of two operands. Let us declare here where and say q is equal to a, use percent b. Let's try to print this q. So I got a 2 result here, b and a. So what will be remainder, you will see it will be 1. So I got the result. Another symbol in dot is another operator, and that is division. The symbol is this. So this performs the same division, but the result is integer. So let us perform operation on a and b. For that we will use where e is equal to a, and then this b, print e. So it's got the 0. This has disregarded this part of it, only print is integer. So if I use here, because this print is in integer, if I say it if I put in data type of e as int and try to run it, this will run, because this division symbol will give me integer. Now let us talk about equality and relational operators. Relational operators test or defines the relationship between two entities. Relational operators return Boolean value, that is true or false. Let's go for practical. For that I will use the same a and b variable 3, where c is equal to a is greater than b. If the a is greater than b, then this c will get true, otherwise false. Let us print it and see, print c. This is called a greater than sign. You can see I got the false because a is not greater than b. If I make it 5a, then I will get the true. It's called greater than. Another is less than. For that I will use another variable z is equal to a is less than b. Let us print z. So I got a true because a is less than b. This dot contains Boolean value. I can make it more readable. For that I will use $sign here and put this in double quotes and add A is smaller or less than B. Control save and try to run it. A is smaller or less than B. That's true. That contains boolean value true. Another is greater than or equal to. Greater than or equal to. If I run it, I got the false. If I make the same 3, you can see I got a true value because A is equal to B. Here also I can change it to equal to, that means A is less than or equal to B. You can see I got a true here. Another operator is equal to. For that I will use where R is equal to A is equal to B. So this will evaluate to true because both A and B are equal. True. Another is not equal to. Let's replace this. This is called not equal to. A is not equal to B. This will return false because A and B are same. If I change it to 2, now this will return true because A and B are not equal. Type test operators that they are used for checking types at runtime, and for that we have is and is not. If I declare I will declare a string here, string with capital S, string str is equal to support, and another, let us say, integer int x is equal to 10. Now both is and is not, they will return boolean value. For that I will use bool data type, bool value is equal to str is string with capital S. If str is string, then this will return true value in value variable. Let us print value I got a true because this str contains string. If I replace it with, let's say, double 10.10, I got the error here. I got the false because this str contains boolean value, sorry, this double value. Another operator is not. For that I will use x variable, bool b is equal to x is not integer, print b. False because this x contains integer, this is saying is not, that is why it is returns false. Let us discuss now about bitwise operators. In bitwise operators we have first bitwise and. I will do it practically for better understanding. First of all, let us declare a variable int a is equal to 5. Then I will declare another variable B, that is 7, and I will declare a var C with I will use the bitwise AND operator A and B. After that I will print it. I will tell you what happens, what this bitwise AND operator does. For that I will first print C variable. So the result will be 5, because what this AND operator does is it will, the binary of 5 is 0 1 0 1. This is the binary of 5, and the binary of 7 is 0 1 1 1. So after performing bitwise AND on A and B, that means 5 and 7, the result will be 5, because this AND operator does is it checks the bit place at this location and this location. If both the two bits are same, then that means 1. If both the bits are 1, then this will return, then this will give 1 at that location, for example in C. So it will give at this place, it will give 1. Now after that you can see 0 here and 1, in that place it will give 0. Another, again you can see 1 and 1, for that it will give 1. Here you can see 0 0, that means it is 0. So if you calculate this is 5 in decimal, that means 1 2 4 8. So 4 plus 1 is 5, so that is why it gives 5 result. So this is what bitwise AND does. Another operator is bitwise OR, and for that I will use the same. Another variable where D is equal to A, then this sign B. After that I will print this D way. You can see here I got the 7. This is because the binary of this, in this case A or B, what it does is it will check if any bit location contains 1. That means here you can see this 1 and 1 will return 1 in OR operation, and you can see 0 and 1 because in both two places it has 1 in one place, so it will return 1. And again you can see 1 and 1, this will also return 1, and in only 0 and 0 this will return 0. So if I calculate it, it will give 1 2 4, that means 4 plus 2 plus 1 7. So this will give 7 result, so that is why this printed 7. So the bitwise AND does, it will check bitwise AND, that is both the two places must have 1, so then it will return 1. If any bit location contains 0, then this will return 0. But in OR case, I mean this operation, it will check if any bit location contains 1. If any bit location contains 1, then it will give 1. Otherwise it will give 0, whether the both bits are 0 or 0 or 0 or 1, that means 1, and 1 and 1, that means 1. So this was bitwise OR. Another operator is bitwise XOR. Bitwise XOR. Bitwise OR. If I will declare a variable where V is equal to A, and for XOR we use this sign. We use this sign A and B. After that, let me print this V variable. Print. Let's first check result, then I will explain you. So it has given me 2. So the X or the binary This is the binary of A and this is the binary of B. After performing bitwise XOR, this it will give me 2, because what it does is it checks two locations, first at this place and this place. The two places must be different. That means if this is 1, it must be 0. If this is 0, then it must be 1. Then it will evaluate, then it will give 1. For example, you can see here this 1 and 1 will give 0, because both are same. And here this 0 and 1, because they are different, it will give 1. Here you can see 1 and 1, they are same, this will give 0. Here again you can see this is 0 and this is 0, so this will also this will give 0. So you can see here only these two locations are different. So if I check, if I give result it, if I try to give result, so this will be 0, this will be also 0, because both 1 and 1, and then this will give 1 because they are different. 0 and 1 are different. At this location it is 0, and then you can see it is 1, then it is 1 and 1, so this will give 0. If I calculated it, this is the binary of 2, 0, 1. This is the binary of 2. So this is what XOR does. Another operator is a bitwise NOT. This bitwise NOT negates, that is, it converts the bit from 1 to 0 or 0 to 1. Let's say if I convert where S is equal to A, that means I am negating the A. I am converting bits of A. That is, 1 becomes, this 1 will become 0, 0 will become 1, and 1 will become 0, this 0, 1. If I try to print it, I will get result -6. So this negates the bits. This converts the bits from 0 to 1, 1 to 0. Another is this is this sign. This is left shift, and this is a right shift. This left shift will shift bits to left. If the bits are, for example, 0 0 1 1 0 0, so this will shift the bits to left. For example, this will convert it into 1 1 0 0. Another is this right shift. So what it does is, if I can take this example, it will, this left shift will target these two and then replace it with here. Zero zero 1 1. So it will shift bits to right side. That's why it's called a right shift. Now finally we have logical operators. Logical operators, you can see here are 2 and the rate of ampersand sign, and logical OR. This means that if A is greater than B and B is less than 10, that means the both these two conditions must be true, then it will return true. This C will return true. And here you can see A is greater than 10 or B is less than 10. That means if any one, either this or this, are true, then it will return true. If any one of them is true, then this will return, D will return true, otherwise false. But in this case it will return true only if both the two conditions are true. Let's run it. You can see I got the true, false, true. Another is NOT operator. So this NOT operator will return true because A is not greater than B. A is 5, B is 7. So this is saying that this is NOT operator, not A greater than B. That means it is true.